Hey coders, welcome back. So let's today again we're gonna solve one of the assessment from LeetCode, and yeah, we have like 20 plus assessment videos, and you can check it out. If you missed anyone, every question has some learning for you also and for me also. So yeah, so these are the sections that are free. The OA one, the phone interview, on-site one. You can select any. So today I'm planning to start with the phone interview one. Maybe up to three questions will be there. The questions are basically generated randomly, and questions quality are really good, I would say, because uh, it's neither very tough nor very easy. So it's a good, practice. So let's start assessment again. So okay, we have only two questions, so that's good. And let's see how it goes. So let me check my screen and all. Yes, I think it's visible. Okay. So the first question says, um, we have an unsorted array. Return the length of longest continuous increasing subsequence, and the subsequence must be strictly increasing. So it says like, okay, this is what is an increasing subsequence is like all the elements should be greater than its previous, right? So, the question is not very tough to understand. So, if this is an array, you have to keep choosing the longest increasing subsequence. So, for example, you can choose like here it's 1, okay, then we are choosing 3 because 3 is greater than 1. Then we can either choose either 5 or 4 or 7, but that is the max. If I choose like 1, 3, 5, uh, and then does that this. Okay, so longest continuous increasing subsequence is 135 with length 3. Even though 1357 is increasing subsequence, it is not continuous as the element 5 and 7 are separated by an element. What? So we have to find continuous increasing subarray, I guess. So then why it is calling subsequence? Length of longest continuous increasing subsequence, that is the subarray. The subsequence must be this. Okay, okay. So it's not a subsequence problem. Subsequence is like you can choose basically one, then five, and then seven. You can take the element or leave the element, but just we just need to like maintain the flow, right? You cannot go backward. But here it is saying like it should be continuous. I don't know why it's confusing. Subsequence part. We just need to find a subarray, basically a continuous set of element that has the longest subarray length. Okay. So for example, you see here, 135 is the longest we can find, right? If I choose the 4, so this is decreasing, right? So 135, that's good. Now, if I take the 4 also, this 4 is less than 5, so that will not be good, right? And it should be strictly increasing, means we cannot take equals to 1, right? It should be greater than, not greater than equals to. If you see the constraint, it says like 10 to the power 4 nums length. So we have to solve it, in the n log n or linear algorithm because if we go like n square, this will give me a TLE. So that's the part. Now, what are the things we can do for solving this problem? So the very first thing that comes into my mind is so what is the easiest way we can solve this? So for example, let me copy this. For any problem, I would recommend try to solve it in the lamest way possible, like whatever worst way you can think of. So if you see, the answer can either be start from one. Okay. So answer can either be start from one, or it can be start from three, or five, or four, or seven, right? So maybe I can just run a for loop. Let's try to make our answer basically longest increasing subarray from 1. So what is the longest we can go? Okay, we can choose 1. Then we can choose 3 because that's fine. 3 is greater than 1. then we're gonna choose 5. 5 is also fine because 5 is greater than 3. But we cannot choose 4. So if I choose 1 as my starting point, this 135 will be the longest subarray that we can make, and the answer will be 3. But if I start from 3, let's say, so I take the 3, then I go to the 5. 5 I can take because 5 is greater than 3, but I cannot take 4, right? So if I start from 3, we can only go to 5. So 2 is the max subarray we can take. Similarly, what if I can do from 5, then from 4, and from the 7, right? So if we have to solve it using n square, it will be very easy as we discussed, right? So n square solution will be something like this. A dot length. I just, let's say this is my starting point. So I is equals to, I will go over each the elements, right? So ai is the basically my starting point. So I can just create a previous value which will keep track of what is the current element we have. And it is like I'm currently AI is the element that is the starting point, right? So that is I'm calling previous. And similarly now I can run a loop from I plus 1, j less than n, and j plus plus. I can maintain a counter how many elements we have seen so far. So counter is equals to 1 because we always gonna choose, we have option to choose at least one element in every cases because that is good, right? So 3, if I just take a one element, so that is the good case, right? So count will always start with a 1, and then I can basically have an answer here. Because if any array is there, so a nums dot length is like 1 to 10 to the power 4, so I can choose any element like 5. So that's a good subarray, right? Because it is single array and it is gonna be like greater than, because there is nothing to compare. So that's why the answer I'm starting with a 1. We can always choose one element. And this for loop is basically as we discussed. We start from 1 and try to make like 3, 5, 4, how many elements we can take, right? Now, before taking, we have to make sure that the current j element should be greater than the previous. So I can just say like if a of j is less than equals to previous, I can just break out of it because this is bad. This is not we want. Otherwise, we can just increase our count plus plus and also change our previous to the current element that we are tracking because we just need to compare the previous element, right? And when I come after of this for loop, I'm gonna have this count will store the longest subsequence, basically subarray that we have seen. If I take AI as my starting point, so I can just make like answer either the math.max of answer comma count. So this simply means either this count which gonna be give me better answer or my previous answer is having the like best answer, and then I can simply return it. So this will be the brute force step. Since we are doing it in two for loops, this will be the n square. So let's run it to see. Okay, I'm getting 3. Let's submit it. We should get a TLE. No, okay, I don't know. So this is kind of like n square, but the good part is why we are able to optimize maybe is because I don't know why. Because it says like nums dot length is like 10 to the power 4, and 10 to the power 4 n square is like 10 to the power 8. So I mean it is acceptable kind of, but yeah, I mean this is the way, I mean then, because as per the number, as per the constraint, we can solve it using n square solution. But I mean I would love to go one level up and try to maybe solve it into the linear way. And for that, what we can do? For that, no, the prefix sum, if you are aware, it's not very similar to prefix sum. It's more like okay, let me copy paste this thing. Control C and then I can comment out. Let's try. I mean, we have time to see if we can optimize it to the linear solution. So, okay, in this solution, you see what are the things that we are doing. So of course, I don't think we can remove this for loop because we wanted to go at least over each element and then check whether we can take that element basically with the help of that element increase our subarray count, right? So one for loop it will be there. We cannot go log in solution, right, for such kind of problem. So only thing is this inner for loop, how we can optimize. So if we look carefully, so what we are doing is we kind of like comparing with the previous. So I mean, when you see something like this, like we are keep tracking a previous and then comparing with the current element and all. So something dynamic programming where it's not like a pure DP, I would say. It's more like a, I would say, observation kind of thing. Because, okay, let me show you what I'm saying. So I can comment out. But I think n square solution will be acceptable as per seeing the constraint, right? So if you don't get it, that's fine. I think our previous solution, this one is fine for this question. So so one thing to notice here is we don't need to give the exact answer, right? Meaning it is not asking for give me answer like the exact subarray that we are able to find like 135. No, this is just asking for the count. So that's the first hint you can get from a question, right? So it is not asking for the actual subarray that is the longest. It is just asking for a count, and this will help you in many questions whenever you see something like this. So remember one more time, this is not asking for a exact give me the subarray. It is just asking to give me the count. So that's the first hint you can get. We just need to focus on count. Now, for this array, if I just make a some space. Now, let's say we have by magic something, right? So for now, just understand like with a magic, we have some answer. Some answer meaning we already have answer for what are the longest subarray we can make. Um, if I start from 7, so I'm saying what is the longest subarray we can make if I start from 7? Of course, 1, right? We can only choose 7 and then we don't have anything, right, in the right side of 7. So, I mean, I can say like 1. I hope this is clear. So, the longest subarray we can make if 7 is my starting point, what it will be? It will be 1, right? I can only choose 7 and we don't have anything, right? So, and now I come to the 4. What is the longest? So I can choose 4, that's fine. But can I also choose 7? I can choose, right? Because 7 is greater than 4. So so what you can take is you can take the help from 7. So whatever the longest subarray you are able to make, I will take your help. If I am smaller than you, so I can just append it to your maximum answer. Since 7 is already having 1, so I'm gonna say okay 4. 4 is less than 7, so I can append my result before 7, right? Basically 4 and 7 is possible. Okay, let's for now let's understand like this too. Because 4 and 7 is possible, right? So I can choose 4 and then I can choose 4 and 7. So I hope this part is clear. Now focus on this one, right? On 5. So, what is the longest we can make from 5? So, I know that I can take 5. That's fine because this is my starting point. Now, can I append my answer to 4? No, because 4 is smaller than 5, right? So, even though if you see like 5 and then 4, so it's not. We want in increasing. So, 5, 4 is not possible. So, from 5, we can only make 1 as my answer, right? Similarly, from 3. Now from 3 you see 3 is less than 5. So I so 3 will say okay I will append my contribution of 1 to this 5. So what is the contribution of 5? 1. And this 3 how many count then it will be? It will be 2, right? I will add myself into the 5 because 5 is greater than 3. So now it's 2. Now similarly for 1. Now 1 is greater than 1 is less than 3 and that is what we want. So it can append itself to the 3, the very next element. So how many element 3 can make? Maximum 2. And how many this can contribute? 1. So what is the answer? 3, right? And then we can simply run a loop and basically get what is the maximum we can make. We can maximum make is 3, and that will be our answer. And that will be linear, right? Because we gonna pre-compute all these values. Again, I'm saying if you're comfortable with this one, that's fine. You don't have to like, but yeah, it's a good question. You can try to write, right? So let's do that. So generally let's call it DP. I mean, you can call it anything. Now we know that dp of n minus 1 is gonna be 1, right? Because from 7 we can only make one element, isn't it? From 7 we're gonna make only one element. Or more better, I can just say arrays dot fill dp1 because all the elements gonna have one as their minimum one will be their starting point. So we can always choose only one element. So from 1 I can choose 1. From 5 at least there will be one element. From 3 there will be one element, right? So I can do that. So I'm basically creating this array and filling 1 into all of its values. Then as we discussed, we're gonna loop from last element. Since I know this for the 7 we know it's 1, so I don't need to calculate for 7. So I'm just going like n minus 2 and doing uh, n minus 2 and obviously I to the 0 and then I minus minus. Then what is the things we need to check? We need to check if a of I is smaller than a of I plus 1. So this means I can attach myself to your answer, right? So this means I can say dp of I is equals to my contribution. This is 1, is like my contribution. And what is the your contribution? So that is I plus 1. Right. So as we discussed in this below part, so if you don't miss that, please watch it again and you will be very clear. Now what we have to do is first we just need to find the maximum of whatever DP. So like we're gonna get the results like this. We just need to iterate over each of the element and return the max. So I can simply say like return arrays dot string. I can use quickly dp dot max dot get as int because it might return optional it return, right? So if we have an empty array we might get a null, and so basically this will help in converting that null value into 0, but we never gonna get null because we always gonna get 1 as my answer. So yeah, now how, let's see how much clear it is, right? And we have only one for loop and this one for loop. So this is a linear. So let's compile it. Okay, I'm getting 3. Let's submit it. Yeah. So this is a more, I mean, I don't know why they're showing like 4 millisecond, but ignore, right? So sometimes it happens. But this is like a more like a solution that you would love to solve it because this is a linear, right? So only one for loop is here. So big O of n, and then this is big O of n. So like big O of 2n, and 2n is like you generally take the upper bound in big O. So that will be a linear solution. And this is our n square solution. So I hope you like this problem. Let's move to the second one. Yeah, so it's a matrix grid kind of problem. So it says like in a gold mine of grid with this dimension, each cell in this mine has an integer value representing gold in the cell or 0 if it is an empty. Return the maximum gold you can collect under the condition. Okay. Every time you are located in a cell, you will collect all the gold in the cell. Now, from your position, you can walk one step to the left, right, up, or down. You can't visit the same cell more than once. Never visit a cell with zero gold. You can start and stop collecting gold from any position in the grid that has some gold. Okay, this is weird. Okay, so I mean, question says like, let's say we have this grid. I mean, let me copy here. Uh, like this, it will be more clear. I can remove this thing. I can remove this thing. Yeah. So this is the grid. Now It says like I think you can start from any position. It's not like you're gonna start from like do we have anything? Uh, all the goals from a position you can walk from right. You can visit the same cell more than once. Never visit a cell with zero gold, and you can start and stop collecting gold from any position in the grid that has some gold. Okay. So it's a and the constraint if I say it's very minimal, right? You say M and N is like 15. So this should give you a hint like it's kind of like brute force. Um, even in the worst case you go, it will not cross like even if you go like 15 to the power 2, right? In the exploring all the path, it will still be very feasible. So that's good. It's more like a, if you, and also on seeing the constraint like this, M and 10, 15, 20, right? You can think of like maybe a backtracking, a recursion kind of problem. So now it says like you can, so you can start from any position. So let's say I start from 8, right? And I can collect gold, right? So from 8, I can go to the 5. Right. So 8, this is the 8, and then from 5, 8, 5, 13, right? And now from 5, I cannot go anywhere because I cannot visit 8 because it's already visited, and I cannot visit 0. I cannot visit this 0. So maybe a zoom. Right. So if you see the answer I'm getting is 24 from 9, 8, and 7. So it says like we start from here, 9, then we visit 8. So 9, 8, 17. And from 8, I can visit 7, and that is like 24. And now from this 7, I cannot visit anywhere. Why? Because this is 0. I cannot visit a cell with 0 value. This is 0. I cannot visit here also. And for this one, we already visited. So we exhausted all our search. So 24 is the answer, right? So it's more like a recursion backtracking kind of problem. There are many problems related to this one. And there is a very like kind of like very standard way to solve this one. It's not, if you are seeing this problem for the first time, don't worry. Just go on the internet and try to search for like backtrack. First, recursion is the prerequisite for this one. Then backtracking, and then how you gonna do like a backtracking on a grid-based problem, right? So it's not. So whatever the question is saying, you just need to do that. It is as simple as that. So what question is saying? I can start from anywhere, right? So let's first do that. So I'm gonna call a helper method. I will call basically DFS. And before that, let's get the dimension of our grid. So m grid dot length and grid 0 dot length. Then we're gonna run a simple for loop from each of these elements. Basically, it says like I can start from anywhere. So this basically I am doing iteration of all the element. I will start from 0, I try to find best answer. I will start from 6, try to find best answer from 0 to 5, 8, 7, everywhere, right? From 7, I will try to find my best answer. So this is the idea. That's why it is for loop, right? And if it is already empty, I don't want to start searching, right? From 0, I cannot because that's not. So from 0, you cannot basically start. So that's what the question says, right? So I can just say like if grid of ij equals to 0, I can simply say continue. I don't want it, right? And let's create an answer variable that will basically keep up the maximum answer we have seen so far. Otherwise, I will say like DFS. I will pass the grid. I will pass my starting position. And basically 0 is something like what is the gold we have seen so far, right? And basically this will help us in giving answer as our best possible result. Basically, what we can do more better way to do this is no, that's fine. Let's move with this one. Then later we can understand. Right. So this is basically we are going over each of the elements and try to build our answer. From 6, what is the max we can go? Right. So from 6, I can go to the 8. So that is 8, 6, 14. Now 14, I can go to the 5, I can go to the 7, I can go to the 9. I will go to the 9. Why? Because it will give me maximum. Because If I move to the 5, I cannot move anywhere. If I move to the 7, I cannot move anywhere. So that's the idea. So let's write our helper method. So public void DFS. This is the grid. This is my current index, and this is the, I would say, current sum kind of. This is what we are able to see. Now we have to make sure that we are not visiting a same cell again. So for that, I will store its value for now. So kind of like int cache, I can call it grade ij, and then I will mark this ij as a -1, or maybe I can mark it as a 0, right? So this is simply means we have visited this cell. You can mark it as -1 also, right? But this is fine. Then I'm gonna move in all those four directions, right? So I can say grid um I sorry DFS grid. Basically, we can move from left, right, up, and down. So this is I plus 1. This is like we are moving down. Current sum plus cache. Similarly, we're gonna copy this four more times because we can move in four direction, right? So I plus 1, this is I plus 1 is below, I minus 1 is one level up, j plus 1 is right, and j minus 1 is left, right? Uh, okay. Now, one more better, no, I think that's fine. This is fine. Now, whenever we are able to basically backtrack all those paths, we also need to make sure that whatever values we are marking visited, we unmark it. So for our next recursion call, right? So I can just say grid ij is equals to cache. So this is basically simulating. We already marked this cache grid ij. We already marked, so don't visit it again. So that's why I'm asking as a like 0. So because for 0 we're gonna add condition. If it is 0, we're gonna ultimately return. So now here I just need to make sure that okay. Now for base cases, you just need to focus here. What are the value that we are changing in this DFS method? So you see I plus 1 we are doing, then j plus 1, j minus 1. So it might get like out of bound. So let's first handle that. So if I is like greater than equals to grid dot length, or I is less than 0, because this is like out of bound condition, right? So j is less than 0, or j is greater than equals to grade 0 dot length, we're gonna return, right? Or maybe something like that. Okay, this is the thing. And also return when grade ij equals to 0, because that path is empty. So that is also a place where we want to return. We don't want to calculate. This is fine. Now for each of this recursive call, we're gonna get answer, right? So we also need to make sure our answer is getting updated. So for that, I can just write here answer is equals to math dot max of answer and current sum that we have seen so far. Isn't it? That's easy. Um, yeah, so I think this is it. So maybe I can try run one more time. But before that, let me see any compile time error. Okay, we have one error and we not returning the answer. So let's do that and run again. I'm getting 24 and let's submit it. Yeah, we are able to solve all those two questions. But before that, yeah, just one more, just like we discussed, right? It's not very complex. It's just like, and this is the thing that you're gonna see in most of the TFS, in a grade-based problem. You're gonna move like this, right? You're gonna always sometimes maintain visited, sometimes not. But some people, I mean, some of the solution you will see they create a Boolean visited array and mark that visited as a true or false. And basically here, instead of checking 0, they check whether that cell is already visited or not. So there are multiple ways to achieve it, but solutions you're gonna see is very standard. Some people basically do, instead of like this, they run this in a for loop. Basically, iterate basically I this all this permutation combination, and that will be solution much cleaner. But there are different way how if you see the solution for this one, right? So again, what we are doing, we are going over each of the position and try to find our answer. What is the max we can go? Right. So I hope you like it. I think both questions were good. There was a learning in all those two questions. Uh, so this one was easy because if you solve it using brute force, this one will be easy, right? So I think this is showing our first solution, but we also have this linear solution, right? So it's not hard. The DP one you can try. Try to understand basically the concept why we are able to do that. And this question was also this is very standard grid based DFS that you're gonna see in lot of problem. So after like 18 days, it's been okay. I'm doing this session again after 18 days. So yeah. So I hope you like it. Uh, let's catch up in the next one. So also I'm trying new thing. So I will start a series where I will be solving like SDE sheet. So this sheet I'm actually trying to understand. So this is like SDE sheet from GFG. It has like 250 problems, right? And it has like array has 21 problems, right? And all these problems. Then we have sorting, string, hashing, binary search, and all. So I'm planning to basically start a series where I will upload all the videos together. So basically all the easy ones at the one time. So you can basically try and solve all the easy ones. Then whenever I'm able to complete all those mediums one, all the medium ones videos will be uploaded like directly. So yeah, this is I'm reading basically and trying to basically how I can make the videos and all. So this is the next thing I'm trying. But I hope you like this assessment. And yeah, let's catch up in the next one.